Hello, geometry folks, and welcome to investigating trapezoids and isosceles trapezoids and kites. So we're going to continue our adventure on talking about quadrilaterals. We spent a little time on parallelograms and the things that follow underneath parallelograms, rectangles, rhombuses, squares. But now we're going to just talk about a couple other figures that don't fall under parallelograms, and that's the trapezoids and kites. So you need your figures for today, you need your notes, you need a pencil, and we will get started. So when you think about a kite, you think about a kite that you're going to fly in the air, and that's exactly where this comes from. And on a windy day, you can fly a kite. And the kite that we are going to use is just the basic shape of a kite is this kite that you see in front of you. If you tape that in your notes and make sure you take good notes on all these properties. So here's some properties. One thing you need to know is that one pair of opposite angles are congruent. Those angles are A and C. So angle A and angle C are congruent. For the sides, you need to know that AB is congruent to BC. And AD is congruent to DC. Okay? And that's what you need to know about angles, and that's what you need to know about sides. Hopefully you're taking good notes. There's a few things we need to know about their diagonals. First and foremost, their diagonals are perpendicular. So when they meet at point E, they will form 90-degree angles all the way around. One of those diagonals is a perpendicular bisector, which means it cuts it in half. Well, basically what this says is that BD basically cuts AC in half. Notice this isn't cut in half, BD isn't cut in half. So AE is congruent to EC, okay? So what we need to know there is that AC is cut in half and will form AE, which will be congruent to EC, all right? We also need to know that the diagonal bisects the opposite angles. Well, if I look at this and I want to write a 1 here and a 2 here, what's going to happen for angle B is that it's going to be bisected. Angle B gets bisected and angle D also gets bisected. So angle 1 and angle 2 will be congruent. Angle 1 is congruent to angle 2. And if I name down here for angle B, if I name this one 3 and 4, angle 3 and angle 4 will also be congruent. All right? So that are all the properties for a kite. Let's go ahead and move on to a trapezoid. So this is what a trapezoid looks like. And notice that AB and CD are kind of slanted. They're kind of slanted inward. So what we need to know about their sides is that they're all different. Not one of them is the same. Okay, they're not congruent to each other. You also need to know that the bases are parallel. So just the bases are parallel though, not the sides. So BC is parallel to AD, okay? For angles, they're all different. Not one of them is the same. And what you need to know is that each lower base is supplementary to an upper base angle on the same side. So angle A and angle B would add up to be 180 because supplementary means 180. So angle A plus angle B would equal 180 degrees. Just as angle C plus angle D would equal 180 degrees. So C would be totally different than A and B, and D is totally different than the other three, but A and B add up to be 180, and C and D add up to be 180. Another thing you want to know about trapezoids is that their diagonals are not unique. There is nothing unique about trapezoid diagonals. Okay, so now we're moving on to an isosceles trapezoid. So remember we've talked about isosceles triangles. So now we're going to talk about an isosceles trapezoid. So their sides have legs that are congruent. Okay, so what's congruent? AB is congruent to CD. So AB is congruent to CD. That's a D. Okay. What else do we know? The bases are parallel. So if we want to call it a trapezoid, and trapezoids have bases that are parallel, well, isosceles trapezoids have to have bases that are parallel. So BC has to be parallel to AD. Okay. Now if we talk about their angles, their upper base angles are congruent. So the upper ones are the ones on top. So angle B is congruent to angle C. And the lower base angles are congruent. So angle A is congruent to angle D. Okay. I'm going to go ahead and erase that right there so it looks more like a D. I'm sorry. So that was CD there. I wanted to make sure that we had that there instead of a B. Okay, moving on. Another thing that we need to know about the angles of an isosceles trapezoid is that any pair of the upper base angles is supplementary to any lower base angle. So if I wanted to say, to make this more or less confusing, I'm going to just take angle B. If I were going to talk about angle B, I could say angle B plus angle A would equal 180. But I also could say angle B plus angle D would equal 180. The reason why I can do that is because A and D are congruent. I could also say the same for angle C. Angle C plus angle A would be 180, and angle C plus angle D would be 180. Okay? And then you should know that the diagonals are congruent. So that means BD is the same length or congruent or equal to AC. Okay? That's on an isosceles trapezoid only, that their diagonals are congruent. Okay, so now we have talked about the three figures that we needed to talk about today. I also want to talk and mention about the midsegment of a trapezoid. So we're going to take a trapezoid and we're going to talk about its midsegment. So when I talk about midsegment, what am I talking about? Well, the midsegment of a trapezoid is the segment that connects the midpoints of the legs, okay? So that means if I look at the legs, I cut both legs in half, I bisect them, okay? Or I find their midpoint, okay? And then I connect those midpoints, and now I have what's called a midsegment. So you want to make sure that you write this in your notes, okay? And what do we want to talk about with midsegments of trapezoids? Well, first, we have to know that we're talking about trapezoids where the midsegment is going to be parallel to the bases. Okay, so it's really important that we're talking about the one that's parallel. The midsegment is parallel to the bases. Okay. And then the other thing that we want to know about the midsegment of a trapezoid is that the length of it is equal to half of the sum of the bases. Okay, so what does that mean? So that basically means that the midsegment is equal to your base, the length of your base, or the measure of base 1 or the bottom base, plus the measure of the top base. So we could say base 1 and base 2. And if we divided that by 2, we would get the mid-segment. So you're going to add both the bases together and divide them by 2, because half means divide by 2, or times it by a half. Same thing. Okay, so let's practice a couple of these and see how well they go. So example number 1, I have a trapezoid, and I know HK is the midsegment. That's important because they're all parallel then, and it's a trapezoid, and I want to find the measure of HK. Okay, I want to know what distance it has. So if we use the formula we just set up in the last side, we would say midsegment. Oops, sorry, got ahead of myself here. Midsegment is equal to base 1. One base is 18, the other base is 6, and if we divide that by 2, we will get the midsegment. So 18 plus 6 is 24, and 24 divided by 2 will be 12 centimeters. So the midsegment HK is 12 centimeters. Okay, let's try another one. If EF is x plus 5, so I'm going to say x plus 5. It's always good to label your figures. And then it says DC and AB add up to be 4x plus 6. So midsegment is equal to the two bases, which are 4x plus 6, divided by 2. And that's equal to the midsegment. We already know the midsegment is x plus 5. So I can go ahead and write, well, I already know the midsegment is x plus 5. So it's x plus 5 equals 4x plus 6 divided by 2. Okay? And then I can solve this as a proportion because I have two fractions on both sides of an equal sign. I have one fraction on this side, one side has another fraction. I can say this is over 1, and I can cross multiply. I can say 2 times x plus 5 would be 2x plus 10. Because remember, you have to distribute the 2 to both the x and the 5. And that equals 4x plus 6. Subtract the 2x from both sides. I get 10 equals 2x plus 6. Subtract 6 from both sides. I get 4 equals 2x. And I get x equals 2. All right, now it isn't asking for the x value. Be careful. Remember, in geometry, we always have to go back and reread our directions. It's asking for EF. So the midsegment EF, the x value is 2. So if we know that midsegment is x plus 5, and we know 2 is our x, 2 plus 5 is 7. And so EF is equal to 7. Okay, that's all I got for today. Thank you for taking good notes, and we will be practicing these tomorrow.